IEEE 1588 is a technique for synchronizing multiple systems in modern distributed systems. It is part of the Precision Time Protocol, or PTP, to get things as accurate, in time, and in sync as possible, and it has gotten down to a nanosecond timing, and it is being looked into to see if it can get even faster than that, and it is constantly evolving. So the uses for IEEE 1588, it's actually intended for systems linked over Ethernet or over Wi-Fi, typically in industrial automation, testing environments, environments for measuring different devices in testing, or something as simple as server and client computers. So IEEE 1588 has a master-slave implementation. And that means that there is going to be one computer that is the main master. And in this animation I have here, number one is that master. So that master is going to send out signals to its other computers, to its other slaves, and it's going to send a sync request. So that first message that it's sending out is checking to see what time those 2 through 5 computers are set to. So if number 1 is set to 1 o'clock, and let's say number 4 is set to 3 o'clock, that would be a 2-hour delay. So that delay request would then get sent out to see if there was any delay. In this case, it takes longer to reach number 5 than it does to reach number 2. So that number would have to be taken into consideration when looking at how long it takes to get information and send information. So just as it does send a signal from the master to the slave, it also sends from the slave to the master to get the delay that it has when sending it that way as well. So as you can see on the left, those are all the different requests it sends, and then it gets a very accurate number to see how long it should wait when sending and receiving information. For change requests, it uses that same system of sending a signal and receiving signals to make an accurate timestamp of when a request was made. If a computer says that it requested something at 1:02, but the master thinks that it's only 12 o'clock, it can calculate exactly when that request was made and the difference between the request and the difference of the time delay. These requests are then put into a queue where it's first in, first out. So if one computer makes the change and another computer right afterwards makes another change, it'll do the first change before the second, and it has about a 2-second refresh rate. That does not include that nanosecond change, the nanosecond delay. That is a 2-second, every 2 seconds, it's going to check to see if any change requests have occurred. If a change request has occurred, it will check to see if any of the other computers have any requests, and if not, or if so, it will make the requests in queue form. Here are the references I used. So I used IEEE 1588 clock synchronization using dual slave clocks in a slave, and that is from EBSCO host, as well as some sources found on IEEE's website.